This is the Stinger missile. In under 5 minutes, we are breaking down how this infrared homing surface-to-air system works, why it is man-portable, and how proportional navigation helps it lock on and destroy fast-moving targets. The FIM-92 Stinger can be carried by a single person, but it can also be configured to fire from ground vehicles and even helicopters in an air-to-air role. Developed in the United States, it has been utilized by the US Army and 29 other nations since the 1980s. It is primarily built by Raytheon Missile Systems, with 70,000 missiles produced under license by Airbus Defence in Germany and Roxanne in Turkey. Despite its compact form, the launcher is about 5 feet long, or 1.52 meters, with a diameter of 2.8 inches, or 70 millimeters, and fins measuring 3.9 inches, or 100 millimeters. The missile alone weighs roughly 22 pounds, or 10.1 kilograms, and about 34 pounds, or 15.2 kilograms, with the launch tube, integrated sight, gripstock, and an identification friend or foe antenna. Inside, the Stinger is organized into 4 major systems: guidance, tail, propulsion, and warhead. The tail contains 4 foldable fins that provide roll and stability in flight. The guidance section packs a seeker assembly, a guidance assembly, a control assembly, a missile battery, and 4 wings that give the missile agility in the air. Up front, the warhead contains about 1 pound or 0.45 kilograms of explosives enclosed in pyrophoric titanium. Driving it all forward, the propulsion system uses a launch motor and a dual-thrust flight motor to get the missile out of the tube and up to speed. Power and cooling are handled in a clever way. A Battery Coolant Unit, or BCU, is inserted into the gripstock to fire the missile. It includes a thermal battery that provides power for target acquisition and a supply of high-pressure gaseous argon that is injected into the seeker to cryogenically cool it to operating temperature. One BCU provides power and coolant for roughly 45 seconds. If the missile has not been fired by then, another must be inserted. The BCU is vulnerable to abuse and has a short shelf life due to argon leaking. For identification friend or foe, the system is powered by a rechargeable battery included with the IFF interrogator box, which plugs into the pistol grip space. When it is time to fire, the soldier aims the weapon at the target. The seeker produces a distinct noise when it latches on. As soon as the trigger is pulled, 2 things happen. A small launch rocket pushes the missile out of the launch tube, away from the soldier, and then the launch engine is detonated and the primary solid rocket engine fires up. From there, the missile automatically flies to the target and bursts. In terms of performance, the Stinger has a range of around 5 miles and can attack targets flying as high as 11,500 feet, or 3,500 meters, with a maximum of 8 kilometers. How does it track? Passive infrared or ultraviolet sensors are used by Stinger missiles to follow targets. They look for the infrared light and heat coming off a target aircraft's engines and chase that signature, while also recognizing the target's UV shadow to help distinguish it from other heat-producing objects. As the missile closes in, the image of the aircraft on the sensor can drift off-center. That tells the guidance system the missile is off course and needs to correct. This is where proportional navigation shines. In simple terms, if 2 vehicles are on course to collide, the direct line of sight between them does not change direction even as the range closes. To stay on track, the missile's velocity vector must rotate at a rate proportional to the line of sight rotation rate and in the same direction. That elegant rule keeps the missile flying an efficient path without constant overcorrection. Mid-video question for you. Which part of this system impresses you most? The cryogenic BCU cooling, the IR and UV target discrimination, or the proportional navigation guidance, and why? Share your reasoning in the comments and let's learn from each other. The Stinger's design compresses complex engineering into a compact soldier-carried package. It marries a lightweight airframe with a smart seeker, disciplined flight control, and a short, reliable firing sequence that prioritizes operator safety. It has also seen real-world use. This missile was used in Ukraine, where it hit a helicopter from a reasonable distance, making it one of the deadliest weapons in the Ukraine-Russia war. If you are into clean, fast breakdowns of tech and innovation, consider subscribing for more videos like this. From guidance laws to sensor fusion, we unpack how systems turn physics into precision. In the end, proportional navigation is more than a formula. It is a mindset for control under pressure. If holding a constant line of sight is the key to a hit, what other real-world systems could we simplify by following the same principle?